we are told we need milk because it contains calcium, and it contains proteins, and it contains all the things that we need. We also know that there are problems with it, and that there are high concentrations of fat and cholesterol, and so some people are advised to take skim milk rather than milk. So is this true, and how good is milk really? Well, the industry has a huge marketing drive, and to compete with the dairy industry in terms of marketing is really quite something. They also have the law on their side. They seem to believe that the word milk belongs to them, and in some countries you may not name any alternative product milk. You must name it something else. So in some countries you may not say soy milk, for example, you must call it soy drink or whatever, because the dairy board would take you to court if you use the word milk. Well, I'm going to use some publications here to show you what the scientific world is saying of this. Of all mammals, human milk has the lowest protein content and the lowest ratio of casein to whey. Now, casein is the protein that you find in milk, and there is a huge production of milk, so if you make evaporated products, then sometimes there is a huge excess of casein in the world, and you can find casein in just about anything, any product, from cookies to baking to power drinks to you name it, you will find casein. And casein is species specific. It's a very specific feeding protein. It's a very compact protein, and it needs special circumstances for digestion. So casein, for example, needs a special enzyme which will unravel it so that it can be cleaved in the normal digestion process. And in infants or in calves, the product that will do that is called renin. And renin curdles the milk and opens up the molecule for digestion. And so animals will produce this either in the lining of the gut. You will find pigs producing this, and calves produce it, and you can use this renin as well as an extract in the cheese production because it will help to curdle the milk. So casein is pretty species specific. The amino acid composition in different species is different. But of all mammals, human milk has the lowest protein content and the lowest ratio of casein to whey. So if we're going to compare them, for example, you will find that in the human there are 1.2 milligrams per liter of casein. That's what there is. And the time required to double the birth weight is 120 days. If you go to the horse, you'll see the horse has exactly double the amount of casein, or protein in general, 2.4 milligrams per liter, and the time to double weight is 60 days. That means exactly half. So there's a very good correlation there. A cow has 3.3 milligrams per liter, and the time to doubling birth weight is 47 days. A goat, 4.1, 19 days. A dog, 7.1 milligrams, 8 days. A cat, 9.5, 7 days. A rat, 11.8, 4.5 days. So if protein is the reason why we drink milk, then the best milk to drink is rat milk. No doubt about it. There's another problem that we have over here. We'll see that the human takes the longest to double the birth weight. Now, when a human is born, the moment the baby is born, he gets up and he walks around and says, "Where's the food?" Right? No, he doesn't do that. What does he do? He's totally helpless. And the brain is still developing. In fact, there are sutures which help it to be born, and the brain is the important structure that still has to develop. The nerves are still connecting up, and so a baby is totally incoordinate, and the nervous system has to develop after birth in a human. A human is a species where the brain is paramount. A cow is not too interested in school and calculus. It's more interested in walking around and feeding. Is that correct? And so, the food type that is geared for a cow is one to make musculoskeletal development possible and is not geared for brain development. So if we feed the human cow's milk, then what we can do is we can induce fairly rapid growth, but it is musculoskeletal growth, and so the baby can get very, very large very quickly, and smaller infants are frowned upon that grow slightly slower. On the other hand, what is it that you would really want to develop properly, the brain or the musculoskeletal development? Well, it depends whether you're a child of a world boxing champion or of a, history professor or something like that, probably. But that's not the point. The point I'm making is that human milk, which has the lowest ratio of casein to whey, is geared for brain development. What does the brain consist of? High levels of proteins, or does the brain consist largely of fat? Basically, our brain is fatty tissue. And there are lots of fatty components. Around each of the nerve fibers, you have myelin sheaths, which are particular fat molecules. So brain and brain connecting tissues or nerve tissues are largely fatty tissues. And so you need that type of development. Children that are raised on cow milk have a lower IQ on average than children that are raised on mother's milk. That's just a fact. So the protein that we find in this food is geared for the species, and if you work with animals in the zoo, you will know that you cannot just feed any milk to any animal. Normally they would die. The human is just so resilient that it can cope with just about any milk out there, and that's why we believe that cow's milk might be good for infants. In fact, the opposite is true. We should strive to use food that meet the nutrient needs of the older infant, yet avoid toxicity. Cow's milk simply does not meet this standard of quality. Journal of Pediatric Gastroenterology and Nutrition. So there are other problems with milk as well in terms of its purity. Here's the journal Pediatrics. You don't get better journals than these in terms of children. Babies who are fed whole cow's milk during the second 6 months of life may experience a 30% increase in intestinal blood loss and a significant loss of iron in their stools. Now, why should the infant bleed internally if it gets cow's milk? The answer again lies in the protein. The casein that occurs in the cow's milk is very hard to digest, which would mean that the situation inside the gut is such that it is more acidic than normal and very irritating to the intestine, so that these young intestines actually bleed in the process and you lose iron that way. And adults have the same problem. People who have ulcers, for example, should never ever have any dairy product in their systems because of the irritating nature of the digestive process involved. Adults who consume large quantities of milk, who have high lactase activity, suffer repeated small galactose challenges, accumulation of galactocol in the lens, and a greater likelihood of developing senile cataracts, postgraduate medicine. Okay, what does that mean now? So the first problem about dairy products is the type of protein. The protein, casein, is very hard to digest. You need very special enzymes in order to do it. And mother's milk has human casein, and the baby would find that hard to digest. But the mother has nodes in the breast where bacteria are raised, which are called Bacillus bifidus, and this bacterium is injected together with the milk and helps to digest the casein. And then the infants also have small amounts of rennin. In a cow, on the other hand, the calf produces large amounts of renin to cope with this huge influx of casein. So that's the way we deal with casein. Once a mammal in general is weaned, then it stops producing renin, and it cannot digest casein adequately anymore. In fact, once an animal is weaned, it should never, ever, ever get milk again, and there is not a mammal in the world that will naturally drink milk after it is weaned. Not a mammal in the world, except the human being. And all of us switch off the enzymes which enable us to digest the casein adequately once we are weaned. So none of us have this. But here's another problem, and that's the sugar in milk. You see, the sugar in milk is lactose. And to digest lactose, you need an enzyme which is known as lactase. And lactase is an enzyme that occurs until you are weaned in most populations. Now, in the white population and in the generally European stock population that has lived in cold climates for many, many centuries, and where people have been raised on milk for a long, long time because that's all they had. They used to plant their grazing in the winter, in the summer, harvest it, and they would have their cows in their sheds, and that's what they would live on throughout those winters. Dairy, 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 dairy. That was the staple food of the European. And so in Europeans, the enzyme lactase continues to be produced after the weaning time, just because milk has never been withdrawn from the diet. But in most other nations where children in Africa, for example, or in Asia are nursed by mothers, and once they are weaned, that's it, lactase ceases to be produced, doesn't get produced anymore. And the enzyme lactase splits the sugar lactose into its two components. The one is glucose, and the other one is galactose. Now, galactose is 1/2 of lactose. Now, in an infant, there's another enzyme which will change galactose to glucose so that they can use it. So there's an enzyme called beta-galactosidase which will take this galactose and change it to glucose as the baby needs it. Now, guess what happens when you're an adult? That enzyme stops being produced. Once you are weaned, you don't produce it anymore. So if you ever consume lactose as a sugar, you might still, if you are a European, have the enzyme lactase that can split the lactose into glucose and galactose, but you won't have sufficient of the enzyme, or none of it as an adult, to split the galactose or to change the galactose to glucose. Which means that no human being actually should ever use lactose as a dietary food ever. Because what do you do with the galactose now that you don't know how to use it anymore? It now becomes a foreign substance in your body. So every time you have a glass of milk and you're converting everything that you can use in there, you will sit with galactose challenges. And what do you do with galactose? Well, you don't know what to do with it, you store it. So you store it in your skin, everywhere, including your eyes, your cornea. And so, senile cataracts largely are galactose deposits which have accumulated over time. So you don't want to do that. What's wrong with dairy products? Here's the Physicians Committee for Responsible Medicine, Washington, D.C. They will tell you that dairy products contribute cholesterol and fat to one's diet. Comparing the cardiovascular status of ovo-lacto-vegetarians and vegans has proven that while both are healthier than meat eaters, vegans have a better cardiovascular status than vegetarians who consume dairy products. And these are all the journals, the Journal of American Medical Association, American Journal of Clinical Nutrition. This has been known for a long, long time. Even the Journal of Dairy Science will admit that milk has been identified as a cholesterol elevating fat because it contains cholesterol and is primarily saturated. That's a half-truth. So I'll acknowledge that they have half the truth there. The other half is worse, which they don't mention, and we'll come to that in a moment. Iron deficiency, we've already spoken about it. Iron deficiency is more likely on a dairy-rich diet. In addition, clinical studies have shown that infants consuming cow's milk lose blood from their digestive tracts. We've dealt with that. Diabetes, this is an interesting one. Insulin-dependent diabetes, that's type 1 diabetes, or childhood onset, is linked to dairy products. And this has been fairly well established over time, and I'll continue with that in a moment as to why that is the case. Ovarian cancer, as the journal Lancet, a Harvard study found that when dairy products consumption exceeds the enzyme capacity to break down galactose, there is a buildup of galactose in the blood which may affect women's ovaries and make them actually infertile. In the European countries, 1 in 4 couples seek fertility help. 1 in 4. That never happens in Africa. Did you notice that? Never happens in Africa. Now here's this cow's milk linked to diabetes. In Lancet Medical Journal in 1999, they found that new evidence published Friday adds weight to a controversial theory that feeding cow's milk to babies may cause them to develop diabetes in later life, the Lancet Medical Journal said. Already in 1978, they said, drinking cow's milk may weaken the immune function in children and lead to problems of recurring infections. A young age and introduction of dairy products and a high milk consumption during childhood may increase a child's risk of developing juvenile diabetes. The journal Diabetologia, 1994. So how come it causes diabetes? What was the theory behind that? Again, it's linked to the protein. This protein casein is very poorly digested, which means that it only breaks down into little bigger chunks. You get energy from it because parts of it are digested, but the pieces sometimes get translocated and end up in the blood as pieces. Now all of a sudden, the body recognizes an abnormal protein. And it just so happens that cow's casein has an amino acid sequence in one part of the molecule which is very similar to the amino acid sequence on the beta cells of the pancreas. So what happens is, when the body recognizes the strange protein, it makes an antibody. And that antibody, if that sequence of amino acids happens to be present in that piece that's in the blood, is an antibody to that amino acid sequence. And then that same antibody attacks your own beta cells and destroys your pancreas. And then you have diabetes type 1, and you have no more insulin producing cells, and then you have diabetes type 1. Then the only solution is to take insulin for the rest of your life. Now, there was a lot of controversy about this because Japanese babies sometimes develop diabetes type 1, even though they never got cow's milk, they only got mother's milk. And so this idea was rejected for a long, long time, until scientists found something very exciting. They found that the Japanese babies that had diabetes type 1 were from mothers who had been subjected to the United States diet. They'd lived in America for a while, and they were using dairy. So they analyzed the mother's milk, and guess what they found in the mother's milk? Cow casein. Why? Because the mother wasn't digesting the cow casein properly. It was also translocated partially into their bloodstream. The body gets rid of it, and a gland throwing things out is a convenient place of getting rid of it. The baby was getting cow casein and making antibodies because it couldn't deal with it, and that's where diabetes 1 came from. So the theory today is pretty well confirmed. Early cow milk exposure may increase juvenile diabetes risk by 1.5 times. Early studies already showed this. Diabetes does not occur in diabetes-prone rodents reared on a diet free of cow's milk for the first 2 or 3 months of life, indicating that cow's milk protein can trigger the disease. The New England Journal of Medicine reported that in 1992 already. They've known this for years. And only now is it slowly filtering through to the medical world that this is actually the problem.